Hi guys, welcome to Periodic Table Part 2. We're going to start out today by talking about valence electrons and reactivity. So very important keyword here is valence electrons. Valence electrons are outer shell electrons. The most electrons that an atom can ever have in its outer shell is 8. 8 is the goal. If an atom has 8 electrons in its outer shell, then it's stable, which is what every atom wants. It just wants some stability in its life. So, important to notice also that the first shell can only have 2 electrons. If it has 2, then it's full. Every other shell, though, can have 8. So 1, 2, 3, 4, 5, 6, 7, 8. The more protons an atom has, the more shells of electrons it has, because remember, the number of protons equals the number of electrons. This atom here has 1, 2, 3, 4 shells of electrons, and in its outermost shell, or its valence shell, it has only 1 electron. So this means that this element is very close to being stable because all it has to do is lose this one pesky electron to become stable. So that's what it would do. So that means that this element is very reactive. Reactivity just means how likely is an atom to interact with other atoms. Some are very, very reactive, like the ones that are here and the ones that are here. The ones that are close to being stable are very reactive, and some of them will never react, and those are the ones here. And we're going to talk about that more in just a little while. Today we're going to talk specifically about the different groups of the periodic table. So remember last time we talked about how the groups are the rows going down the table. There are some really important different groups that are also known as families, and they're called families because the elements are closely related. They act very similarly to each other, even though they have different numbers of protons and electrons. Every family has a specific name to tell the difference from the other families, and the elements in the families react similarly but differently to the other elements that are in other families. You can see in this periodic table that the different families have been colored similarly, so every different color is a different family of elements, which you can see the key for right here. You might remember from last time that the elements that are on the left side of the periodic table, with the exception of hydrogen, are the metals. So it makes sense that the first family would be called the alkali metals. This is the first row, the first column, of the periodic table. Elements that are in this family do not include hydrogen, so hydrogen is by itself not part of the alkali metals. This is the most reactive family on the periodic table. So think of them as the family that always is having big explosive fights. They're very reactive. They're rarely found free by themselves in nature because they're always reacting with another element. They always form ions that have a charge of +1, which makes sense because in their outer shells, they have 7 electrons. So, for example, here is sodium. Sodium has 11 electrons, and so it has 3 electron shells. The valence shell is the third one, and it has 1 electron in it. So, because it's easier to lose 1 electron than it is to add 7, sodium is going to try to give this electron away to another element, and it's going to become a positive element because it has lost a negative electron. Other facts about the alkali metals are that they are soft, silvery, and shiny. They're very reactive, especially with water, and they conduct electricity. Next up is group or family number 2. These are called the alkaline earth metals, so they're still metals. They are still very reactive. They form ions of +2. So they have 2 electrons in their outermost shell. It's easier to lose those 2 electrons than to add 6, and so they become positive ions. These elements are white, silvery, and malleable, and they also conduct electricity. Next up is the only family that's not one column. These are called the transition metals, which makes sense because they are transitioning from the metals to the nonmetals. These metals are pretty diverse. They are found freely in compounds and also in nature. They form ions. Usually these ions are +2, but not always. So some of them have different numbers of valence electrons, but it's usually 2, +2, similar to the earth metals. These are almost all solids at room temperature except for mercury, which is here. Mercury is a liquid at room temperature. You've seen it in thermometers. And they're good conductors of heat and electricity. Most of the common metals that you know about are found in the transition metals: silver, gold, platinum, zinc, copper, nickel. These are all common metals that you think of when you think of metals, and they are found in the transition metals. The lanthanides and the actinides are also included in the transition metals. They should be inserted in the periodic table right here. They are pictured below because if they were inside of there, it would be so long, the periodic table, that it would be really hard to look at. They're also sometimes called rare earth metals. The next couple of families are named for the first element in their family. So this is the boron family, column number 13. These form ions with a charge of +3 because they are going to lose 3 electrons. It's easier than adding 5 electrons. And they are commonly found, they're metals, and they can be found in compounds or on their own. Next up is group 14. These are the carbon family. It contains some metals and some metalloids. The carbon family creates unusual bonds. Carbon and silicon can both make double bonds or even quadruple bonds with other elements. These can form ions of +4 or -4 because it's the same to either lose 4 or gain 4, but they often don't form ions. They're often found just in their neutral form. Group 15 is the nitrogen family. These elements have 5 valence electrons, and they will form ions of a -3 charge. They will add 3 electrons to achieve stability. This family contains some nonmetals, some metalloids, and some metals, so it's pretty diverse. The oxygen family is group 16. It's sometimes called the chalcogens. These elements form a -2 ion. They add 2 electrons and become more negative. They have 6 valence electrons. Now we're back to unusual names in group 17. These are called the halogens. They're the most reactive nonmetals, and they form ions with a charge of -1 because they only have to add 1 electron to achieve 8 electrons, which is stability. Finally, the last group, group 18, is the noble gases. They are also called inert gases. Inert means that they don't react. They do not form ions because they have 8 valence electrons if they are neon on down, and they have 2 valence electrons if they are helium, which is also considered stable because they only have 1 shell. So now that you know about all of the families, there are some overall periodic table trends that are important. As you move towards the left, you get more metallic. The metals are over here. As you move towards the right, you get more non-metallic. These are the gases. The atomic radius increases as you move to the left and as you move down. So the most dense element is osmium, which is down here in this corner. Electron affinity means the willingness of an atom to accept electrons. And so, of course, as you move down here to the halogens, which only have 7, or which have 7 valence electrons, they're more likely to add an electron than the other elements are. Right now, don't worry about these ionization energy and electronegativity. They're not super important for what we're talking about. That's it for this week. Hopefully you learned something new about the periodic table. Don't forget to do your discussion post, and I'll see you next time. Bye.